Hello students, this is Mr. Anderson and this video is on graphing the inverse function. We will be using an input-output table to get a set of ordered pairs, and from this set of ordered pairs we will be able to find the graph. So let's take a look at the parent equation, y equals 1 over x. To do this, just like in similar videos, we're going to show our work in here and find the output value. So when we put in the value for x of -2, we end up with an output of -1/2. When we put in -1, we end up with -1. When we put in -1/2, one divided by -1/2, we will get a value that is -2. When we put in 0, 1 over 0 is undefined. You will get an error on your calculator, so I'm going to just denote that here with a little dash. When we put in the value 1/2, we're going to get the value 2. When we put in the value of 1 divided by 1 is 1. When we put in 2, we'll get an output value of 1/2. And now we're going to connect our points, or put our points on here, and then connect them. This is actually kind of interesting the way this turns out. -2, -1/2, that's your first one, so we're going to go left 2 and down 1/2. That point there. -1, -1, so we're going to go left 1, down 1. And then -1/2, -2. It's going to end up looking like that. Then at 0, you don't have an output value, so we cannot graph anything on this y-axis. If we go to this next ordered pair, it will be 1/2, 2, so we're going to go to the right 1/2 unit and up 2 units. 1, 1, so we're going to go right 1 and up 1, and 2, 1/2, so we're going to right 2 and up 1/2 units. Now, I say this is interesting, or to a math teacher at least it's interesting, because here's what's going to happen. We cannot touch, as we discussed earlier, since we don't have a real output value, we actually cannot have a line that touches either the x-axis or the y-axis. So your graph actually looks like this. It's in 2 parts. It is not continuous. Okay? And like I said, your graph actually will never touch the x-axis or the y-axis. And when they never touch, but they get really close to it, that has a special name. They call that asymptote. Asymptote. And so your y-axis is an asymptote, but also your x-axis is an asymptote. And by that I mean the graph will never touch either of those 2 axes. It'll get really close, but never actually touch. Let's look at a couple other examples. We have y equals 1 over x, the quantity of x plus 2. And so when we do this, we'll have to make sure we do the x plus 2 piece first before we divide. Remember our correct order of operations. -4 plus 2 is -2, and so your output value here is -1/2. We put in a value of -3. -3 plus 2 is -1. 1 over -1 is -1. when we put in 2.5, negative 2.5 minus plus 2, you get negative half. 1 divided by negative 1/2, you get negative 2. When you put in negative 2, you're going to end up with 0 in the denominator again, and so this is undefined. Here you actually end up with 1 over 1/2, which will give us a value of positive 2 now. This here, negative 1 plus 2, be 1. And then you have 1 over 0 plus 2, which will give you a half. And we're going to go ahead and plot the ordered pairs, negative 4, negative 1/2, negative 3, negative 1, and negative 2.5 down to. And your other piece will be negative, you cannot do negative 2 on the x-axis because that's undefined, negative 1/2, 2. Negative 1, 1, and 0, 1/2. Now you can connect those points. We know that at negative 2 it will not touch, so you have an asymptote here. That is the x-axis, and at this value where x is negative 2. Let's take a look at one more. Try this one on your own, and then come back and check, see if you get the right answer. You'll need to pause it. Here, what we're going to do is we're going to subtract 4 after we divide. So 1 over negative 2 minus 4, you're going to get negative 4.5. When we put in the value negative 1, 1 over negative 1 is negative 1, negative 1 minus 4, negative 5. When we put in negative. So now we're going to go ahead and graph. Negative 2, negative 4.5, so we're going to go left 2, down 4.5. Negative 1, negative 5. Negative 1/2, negative 6. Then 1/2, 2, negative 2, excuse me. 1, negative 3. And 2, negative 3.5. And there you go. You have an asymptote now that is the y-axis. And you have an asymptote now where x is 0.